Hi everyone, welcome to the course on chemistry. In that we are discussing about surface chemistry. So in the previous video we have studied about the cleansing action of soap and the chemical and physical methods of preparation of colloidal solutions. Today we will discuss about purification of colloids, because once you prepare the colloidal solutions, those colloidal solutions will consist of certain impurities, mainly electrolytes, or you can say crystalloids. Crystalloids or electrolytes, they are having the particle size less than 1 nanometer, because while preparing the colloidal solutions we will add certain electrolytes to the colloidal solution, and hence after preparing the colloids, the electrolytes will remain along with those colloidal solutions, and therefore we have to remove those crystalloids or electrolytic particles which are present along with the colloidal solutions. For this purpose we will carry out different purification processes. So let us study what are those purification methods which are used to remove the impurities from the colloidal solutions. Before that, what is purification of colloids? That we will study. So the process used for reducing the amount of impurities to a requisite minimum is known as purification of colloidal solution. ಯಾವುದೇ ಒಂದು ಇಂಪ್ಯೂರಿಟೀಸ್ ಅನ್ನ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ದಿಂದ ರಿಮೂವ್ ಮಾಡುವಂತ ಪ್ರೊಸೆಸ್ ಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಪ್ಯೂರಿಫಿಕೇಶನ್ ಆಫ್ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂಡ್ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಮೆನ್ಷನ್ಡ್ ಒನ್ ಟರ್ಮ್ ದಟ್ ಈಸ್ ರಿಕ್ವಿಸೈಟ್ ಮಿನಿಮಮ್. ದಟ್ ಮೀನ್ಸ್ the electrolytes are not completely removed. There will be presence of certain amount of electrolyte along with the colloidal solution. Okay, so how much electrolyte should be removed, that we have to decide while removing the electrolytic particles from the colloidal solution, and this process is said to be purification of colloidal solution. So we use different methods. So let us study what are those methods. The first one is dialysis. What is dialysis means? Dialysis is a process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable membrane. As you know, diffusion means movement of particles from higher concentration to lower concentration. In a colloidal solution, the electrolytes are present. Those electrolytes are diffused through the small pores which are present on the membrane, and they get easily diffused from those pores, but not colloidal particles. ಏನಿರ್ತಾವ್ರಿ, ಒಂದು ಮೆಂಬ್ರೇನ್ ತಗೊಂತೀವಿ, ಆ ಮೆಂಬ್ರೇನ್ ಒಳಗೆ ನಾವು ಏನು ಆ್ಯಡ್ ಮಾಡಬೇಕು, ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ನ ಆ್ಯಡ್ ಮಾಡಬೇಕು. ದ್ಯಾಟ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಇಂಪ್ಯೂರಿಟಿ. that membrane consists of small pores ಇರ್ತಾವ ಆ ಮೆಂಬ್ರೇನ್ ಒಳಗೆ. ಆ ಸ್ಮಾಲ್ ಪೋರ್ಸ್ ಥ್ರೂ ಏನಾಗ್ತಾವು, ಇಂಪ್ಯೂರಿಟೀಸ್ ಈಸಿಯಾಗಿ ಡಿಫ್ಯೂಸ್ ಆಗ್ತಾವ, ಅಂದ್ರೆ ಮೂವ್ ಆಗ್ತಾವ. ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಬಿಗ್ಗರ್ ಸೈಜ್. ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೈಜ್ ಏನಿರುತ್ತಿ ದೊಡ್ಡದಿರುತ್ತೆ. ಅದಕ್ಕೆ ಆ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ ಏನಾಗ್ತಾವು, ಇಟ್ ವಿಲ್ ರಿಮೇನ್ ಇನ್ಸೈಡ್ ದ್ಯಾಟ್ ಆಫ್ ದಿ ಮೆಂಬ್ರೇನ್. ಆ ಮೆಂಬ್ರೇನ್ ಒಳಗಡೆನೆ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಉಳ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಅಷ್ಟೇ ಏನಾಗ್ಬಿಡ್ತಾವೆ, ಹೊರಗೆ ಹೋಗ್ಬಿಡ್ತಾವೆ. ಆ ಒಂದು ಪ್ರೊಸೆಸ್ಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಡಯಾಲೈಸಿಸ್ ಪ್ರೊಸೆಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಸೊ ರಿಮೂವಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಫ್ರಮ್ ದಿ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ ಬೈ ಮೀನ್ಸ್ ಆಫ್ ಡಿಫ್ಯೂಷನ್ ಥ್ರೂ ಎ ಸುಟೇಬಲ್ ಮೆಂಬ್ರೇನ್ ಈಸ್ ಸೆಡ್ ಟು ಬಿ ಡಯಾಲೈಸಿಸ್. ಆ್ಯಂಡ್ ದಿಸ್ ಡಯಾಲೈಸಿಸ್ ಪ್ರೊಸೆಸ್ ಈಸ್ ಕ್ವೈಟ್ ಸ್ಲೋ. ಈ ಪ್ರೊಸೆಸ್ ಏನಿರುತ್ತೆ ರೀ, ಭಾಳ ಸ್ಲೋ ಆಗಿ ನಡೀತದೆ. ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ಟು ಎಕ್ಸಲರೇಟ್ the rate of this process, we will apply the electric field around that dialysis process, and hence that subject of electric field leads to the increase in the rate of the dialysis process. Now electric field apply ಮಾಡಿದಾಗ ಆ ಡಯಾಲೈಸಿಸ್ ಪ್ರೊಸೆಸ್ ದ ಸ್ಪೀಡ್ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗುತ್ತೆ. and thus that kind of dialysis is said to be electrodialysis. So electrodialysis is the process of dialysis of colloidal solution which is carried under the effect of electric field. Then ultrafiltration. So ultrafiltration, it is the process of separating the colloidal particles from the solvent and soluble solutes present in the colloidal solution by specially prepared filters. ನಾವಿಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಿ ರೀ, ಅಲ್ಟ್ರಾ ಫಿಲ್ಟರ್ ಪೇಪರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ಅಲ್ಟ್ರಾ ಫಿಲ್ಟರ್ ಪೇಪರನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಫಿಲ್ಟ್ರೇಷನ್ ಮಾಡಿ ಕೊಲಾಯ್ಡ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸನ್ನು ಸಪ್ರೇಟ್ ಮಾಡ್ತೀವಿ. ಆ ಪ್ರೊಸೆಸ್ಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಅಲ್ಟ್ರಾ ಫಿಲ್ಟ್ರೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ದಿ 3 ವೇರಿಯಸ್ ಮೆಥಡ್ಸ್ ವಿಚ್ ಆರ್ ಯೂಸ್ಡ್ ಟು ಪ್ಯೂರಿಫೈ ದಿ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್. ಸೊ ಲೆಟ್ಸ್ ಸಿ ಹೌ ದೀಸ್ ಪ್ರೊಸೆಸಸ್ ವಿಲ್ ವರ್ಕ್. ಯಾವ ರೀತಿ ಈ ಪ್ರೊಸೆಸ್ಸನ್ನು ಕ್ಯಾರಿ ಔಟ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನ ನೋಡೋಣ. ಸೊ ಮೆಥಡ್ಸ್ ಆಫ್ ಪ್ಯೂರಿಫಿಕೇಶನ್ಸ್. ಆಸ್ ಯು ನೋ, there are 3 different types of purification. One is dialysis, that is carried out by membrane. Another one is electrodialysis, that is carried by electricity. And ultrafiltration, that is carried by using ultrafilter paper. So these are the 3 different methods of purifications, and they are carried by different ways. In purification of colloids by dialysis, a dialyzing membrane is placed in a container, and that dialyzing membrane consists of the colloid and impurity. The pink particles that you are observing are said to be impurities, and larger particles are said to be colloidal particles. And it is placed in the container where water is continuously flowing. Upon that, the impurities will get diffuses from that membrane, and you will get the water and impurities from the outlet, and the colloidal particles will remain in the dialyzing membrane. So next one, purification of colloids by electrodialysis. It is similar to that of the dialysis, but it consists of the electrolytes or crystalloids as impurities. Upon subjected to electric field, the positively charged and negatively charged ions, they will get attracted towards the electrodes. If you say it is positive, then the negative particles will attract towards positive, and positive particles will attract towards negative. So due to the subjection of electric field, the movement of ions becomes faster, and we will get the pure colloidal particles inside the dialyzing membrane. Next, purification of colloids by ultrafiltration. So when you observe this ultrafilter paper, it allows to pass impurities easily, but does not allow to pass colloidal particles because the pores size is very small, and impurities are having smaller size, and hence they can easily pass through that ultrafilter paper, but colloidal particles will not able to pass through that ultrafilter paper. Now let us study how we will make this ultrafilter paper. So when there is a presence of large filter paper and common filter paper, it consists of large sized pores, and this can be minimized by soaking that filter paper in the colloidal solution. So colloidal solution is nothing but 4% solution of nitrocellulose in a mixture of alcohol and ether. Then it is treated with formaldehyde, and it becomes hardened, and then it becomes dried. Okay, and hence this pores size will becomes smaller, and colloid cannot pass through that pores. So this is how we can carry out the ultrafiltration process to purify the colloidal solutions. Now let's study the next concept, that is properties of colloids. So what type of properties will be shown by the colloids? The first one, colligative properties. As you know, the colligative properties means these are the properties which mainly dependent on the number of particles which are present in a solution. If the number of particles increases, the value of colligative properties will also increases. If the number of particles gets decreases, the value of colligative properties will also decreases. Now, in the case of a colloidal solution, the colloidal particles are bigger aggregates. Okay, the size of the colloidal particles is larger. And when we consider the true solution, the size of the particles is very small. Now, if I consider 1 liter of colloidal solution and 1 liter of true solution, in which of those solution the number of particles is more? ಈಗ 1 ಲೀಟರ್ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ 1 ಲೀಟರ್ ಟ್ರೂ ಸೊಲ್ಯೂಷನ್ ತಗೊಂಡಾಗ ಯಾವ ಒಂದು ಸೊಲ್ಯೂಷನ್ ಒಳಗ ಹೆಚ್ಚು ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತಾವ, ಹೆಚ್ಚು ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರ್ತಾವ, then you can say that the number of particles will be more in case of true solution. ಟ್ರೂ ಸೊಲ್ಯೂಷನ್ ಒಳಗ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಿರ್ತಾವ್ರಿ ಜಾಸ್ತಿ ಇರ್ತಾವ. ಯಾಕೆ ಜಾಸ್ತಿ ಇರ್ತಾವ? Since we have taken 1 liter only in both the cases, ಎರಡು 1 ಲೀಟರ್ ತಗೊಂಡಿವಿ, ಬಟ್ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಟ್ರೂ ಸೊಲ್ಯೂಷನ್ಸ್ ಒಳಗೆ ಹೆಚ್ಚಿರ್ತಾವು. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೈಜ್ ಏನಿರುತ್ತೆ ರೀ, ಸ್ಮಾಲ್ ಇರುತ್ತೆ. ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇರೋದ್ರಿಂದ ಹೆಚ್ಚು ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ 1 ಲೀಟರ್ ಒಳಗೆ ಏನಾಗ್ತಾವು, ಪ್ರೆಸೆಂಟ್ ಇರ್ತಾವೆ. ಅದ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೈಜ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗುತ್ತೆ. ಓಕೆ, ಸೈಜ್ ಇಸ್ ಬಿಗ್ಗರ್ but the number of particles is less, and hence the value of colligative properties is smaller for colloidal solution as compared to the true solution. True solution ಗೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ colloidal solution the colligative properties value ಏನirtavri ಕಡಿಮೆ ಇರ್ತಾವ, because the number of particles is less in colloidal solution and the number of particles is more in true solution. What are the colligative properties? Osmotic pressure, lowering in vapor pressure, depression in freezing point, elevation in boiling point, that you have already learned in the chapter solution. Okay, so this is the property of colloidal solution. Then second property is Tyndall effect. The Tyndall effect is the scattering of the light by the particles present in the colloidal solution when viewed at right angles to the passage of light. Tyndall effect ಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಫ್ ಲೈಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ಯು ಮೇ learned about this Tyndall effect. Okay, because why sky is blue, sky adak blue ada, why rainbow will be formed. Okay, all those can be explained with the help of Tyndall effect. Okay, so Tyndall effect, it is simply nothing but the scattering of light, and that property was shown by colloidal solution because the particle size is bigger and they are able to scatter the light which is passing through the colloidal solution, and hence the path of the light is become visible in the colloidal solution. But in case of true solution, we are not able to see the Tyndall effect because the particle size is very small and hence they will not able to scatter the light. Okay, and this Tyndall effect is observed only when, okay, there are two conditions. The diameter of the dispersed particles is not much smaller than the wavelength of light used. ಈಗ ಯಾವ ಲೈಟ್ ಪಾಸ್ ಮಾಡ್ತಿರ್ತಿರಲ್ಲ ಆ ವೇವ್ಲೆಂತ್ ಆಫ್ ಲೈಟ್ ಮತ್ತು ಡಯಾಮೀಟರ್ ಆಫ್ ಡಿಸ್ಪರ್ಸ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅದು ಏನಿರಬಾರ್ದು, ಸ್ಮಾಲ್ ಇರಬಾರ್ದು. ಯಾವುದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ವೇವ್ಲೆಂತ್ ಆಫ್ ಲೈಟ್ ಯೂಸ್ಡ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಒನ್ ಕಂಡೀಷನ್. ಅಂಡ್ ಅನದರ್ ಒನ್ ಈಸ್ refractive indices of the dispersed phase and dispersed medium have large difference. Refractive indices ಏನಿರಬೇಕು, ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಮತ್ತು ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ ಮತ್ತು ಬಹಳ ಡಿಫ್ರೆನ್ಸ್ ಜಾಸ್ತಿ ಇರಬೇಕು. ಸ್ವಲ್ಪ ವೇರಿಯೇಷನ್ ಇದ್ದಾಗ ಸ್ಕ್ಯಾಟರಿಂಗ್ ನೋಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗೋದಿಲ್ಲ. ವೆನ್ ದೇರ್ ಇಸ್ ಎ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಲಾರ್ಜ್ ಡಿಫ್ರೆನ್ಸ್ you can clearly observe the Tyndall effect. So this is one effect or the property which is shown by colloidal solution. Then third one, color. The color of the solution depends on the wavelength of the light scattered by the dispersed particles as well as size and nature of the dispersed particles. For example, the finest gold soul is red in color. Gold soul ತಗೊಂಡಾಗ ನೀವು ಇನಿಷಿಯಲಿ ಏನಿರುತ್ತೆ ರೀ ರೆಡ್ ಕಲರ್ ಇರುತ್ತೆ. ಸಪೋಸ್ ಆ ಗೋಲ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋತು ಅಂತ ಹೇಳಿದ್ರೆ the color changes to blue, then purple and finally gold. Gold soul initially small ಇದ್ದಾಗ particle size red color ಇರುತ್ತೆ ರೀ. ಹೆಚ್ಚು ಆಗ್ತಾ ಹೋದಂಗ blue, purple, finally gold color ಗೆ ಏನಾಗುತ್ತೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. Because the variation in the scattering will be observed and hence the color of the colloidal solution will become changes. It depends on the wavelength of light, size and nature of the dispersed particles and the manner in which it is viewed. If you change the angle through which you are viewing, then the color of the solution will also changes. And then another one is Brownian movement. This is one of the special property shown by the colloidal solution. Brownian movement means it is the zigzag movement of the colloidal particles in a colloidal solution, and again it depends upon the size of particles and viscosity of the colloid. Brownian movement ಅಂತ ಹೇಳಿದ್ರೆ colloidal particles ಏನಾಗ್ತಿರ್ತಾವ್ರಿ zigzag random manner ಒಳಗೆ ಮೂವ್ ಆಗ್ತಿರ್ತಾವ. ಆ ಮೂವ್ಮೆಂಟ್ ಗೆ Brownian movement ಅಂತ ಹೇಳ್ತೀವಿ. Brownian, it is the name of the scientist Robert Brown has identified this and hence it is said to be Brownian movement. And this Brownian movement is caused due to unbalanced bombardment of particles by molecules of the dispersion medium. ಯಾಕೆ ಇದು ಕಾಸ್ ಆಗುತ್ತೆ ಆ ಬ್ರೌನಿಯನ್ ಮೂವ್ಮೆಂಟ್ ಯಾಕೆ ಜಿಗ್ಜಾಗ್ ಮೂವ್ ಆಗ್ತಾವ ಅಂತ ಹೇಳಿದ್ರೆ ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮತ್ತು ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಒಳಗಿರುವಂಥ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಂದಕ್ಕೊಂದು ಕೊಲೈಡ್ ಆಗೋದ್ರಿಂದ ಅಲ್ಲಿ ಏನಾಗತ್ತೆ ರೀ ಮೂವ್ಮೆಂಟ್ ಜಿಗ್ಜಾಗ್ ರ್ಯಾಂಡಮ್ ಆಗಿ ಏನಾಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವೆ ಮೂವ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತಾವೆ. ಸೊ ರಿಮೆಂಬರ್ the cause for Brownian movement, important for the examination. What is Brownian movement and what is the cause for Brownian movement? They may ask like this in the examination, so you have to write this cause. Okay, then the next property is charge on colloids. The colloidal particles are charged, means they have either positively charged or negatively charged particles. If the colloidal particles in a colloidal solution are positively charged, then it is positively charged colloidal solution or positively charged salts. If the colloidal particles in a colloidal solution are having negative charge, then that kind of colloidal solution is negatively charged salt. And examples for these kinds of salts are hemoglobin, oxides like titanium dioxide solution, hydrated metal oxides like aluminum oxide, ferric oxide. These are the examples for positively charged salts. And for negatively charged salts, metal salts like copper, silver, gold salts, and metallic sulfides, acid diesters, salts of starch, gelatin are the examples for negatively charged salts. So these are the some properties of a colloidal solution. And what causes the charge on colloids? ಯಾಕೆ colloidal particles charge ಅನ್ನು ಹೊಂದಿರ್ತಾವೆ, ಪಾಸಿಟಿವ್ ಆಗಲಿ ನೆಗೆಟಿವ್ ಆಗಲಿ, why they are charged? Okay, so that we will discuss in the next video.